Okay, we're now at section 17.3, current and voltage measurements. You've already, at least you've done voltage measurements in the lab. We'll discuss this a little bit more here. Let's move this to the side. All right, the circuit shown in the figure on the left is a drawing of a circuit set up to measure current. The figure on the right is the circuit diagram for this setup. This circuit consists of only a battery and a light bulb. The battery pumps charge through the bulb and around the loop. No charge would flow without a complete conducting path from the positive terminal of the battery into one side of the bulb, out the other side, and through the copper conducting wires back to the negative terminal of the battery. The important quantities for the bulb in this circuit is the current I in the bulb and the potential difference delta V across the bulb. Let's say we want to measure the current. We place the device called an ammeter in line with the bulb. This way, all the charge passing through the bulb must also pass through the ammeter. A voltmeter measures the potential difference or voltage between the two ends of the bulb's filament. Okay, this is a photo of a digital multimeter. You've already seen one in the lab yesterday. This is a device that can be used to measure voltage, current, and resistance. An advantage of using a digital multimeter as a voltmeter is that it will usually not affect the current because a digital meter has enormous resistance to the flow of charge in the voltmeter mode. Now you can see how you can measure the voltage as a function. Now you can see how you can measure the current as a function of voltage, an I versus delta V curve, various devices in the lab. All you need is a variable voltage supply, which can supply potential differences from about 25 to 15 volts, a bulb, a resistor, some wires, and alligator clips, and a couple of multimeters. When making measurements, be sure to always start your measurements using the highest multimeter scale, say 10 amps and 1,000 volts, and increase the sensitivity one scale at a time to obtain the highest accuracy without overloading the meters. Increasing the sensitivity means lowering the maximum current or voltage that the scale reads. Now, I want to go back to the circuit here. If you look at the circuit diagram, if you look at the bulb and you look at the voltmeter, you'll see that those are in parallel. If the voltmeter had a very low resistance, part of the current would come out of the plus side of the battery, go into the bulb, but it would also go into the voltmeter. In other words, if the voltmeter doesn't provide much resistance, the current would split going through the bulb and through the voltmeter. That's why a voltmeter should have very high resistance. Now, on the other hand, if you look at the ammeter in line with the bulb and the voltmeter for that matter, the ammeter should have very low resistance because you don't want it to affect the current flow that much. So a voltmeter should have high resistance and an ammeter should have low resistance. That concludes this section. Next, we will discuss resistance, resistivity, and Ohm's law.